Good afternoon, everyone, and welcome. Today in the session, we're going to be discussing MEP engineering. I know you're asking, what is MEP? Well, MEP stands for Mechanical, Electrical, and Plumbing. And the type of engineering that we do is we design those systems for commercial buildings and some residential buildings. And another term for MEP engineering is architectural engineering. You'll hear that a lot. It's a type of architectural engineering. So today we will go over who's presenting. We're going to go over the project that we're going to be presenting on. It's similar to the kiosk you're working on. It's a smaller project that involves all different types of systems. We're going to go over plumbing engineering, fire protection, fire alarm, mechanical engineering, and electrical engineering. And then at the end, we'll go through construction administration, which is a another part of our job, and we'll go over your student lesson and talk through any questions you might have on our presentation. So my name is Morgan Gunner. I'm an electrical engineer. I've been with Optima Engineering for about 8 years now. Um, how I got into electrical engineering is kind of through my family. My family's been in the electrical business for 4 generations now, as electrical contractors and also as project supervisors. Um, I kind of got I didn't know what I wanted to do when I was in high school, and my dad, he's like, well, you know what, you should try engineering. Cool job. You make a decent amount of money, good living off of it. So I went to college, and that's what I stuck with. I ended up going to UNC Charlotte, which they've got a great engineering program. I highly recommend it. They got great professors, and you really dig into the material there, and they teach you how to apply it to the like real world situation. Well, while I was in school, I got a internship opportunity with Optima, and ended up taking it, and I worked there till I graduated, and they ended up hiring me for their one of their Raleigh office electrical designer positions out of school. So I ended up moving back to Raleigh, and worked here for 4 years and decided to try and take the PE exam. So I ended up taking that and passing it, and I highly recommend. That's another goal I would recommend for anybody that decides to do engineering is try and get your PE exam, because it opens the doors for new opportunities and new positions within a company. With that, I'll turn it over to Spencer.
Hey, my name is Spencer Dearman. I graduated about a year ago from North Carolina State University. Electrical and computer engineering was my undergrad. Um, I've been with Optima for 3 years. As a junior in college, I got an internship here with Optima, and I would recommend that for anyone that's no matter what you go into. I would recommend looking at internships and co-ops and that kind of thing to really get hands-on experience in whatever field that you're going into. That led me into electrical designer job here. Here in 3 years, I've got to work 4 years until I can get my professional engineering um, title like Morgan has. But I've already, before you take the PE, you have to take the FE, which is the fundamental engineering exam. And so just passed that. So on my way to being a PE, in kind of like learning as much as I can from Morgan every day, and just kind of learning the field. So let's get into this project. So what we do here at Optima Engineering, we do MEP, that's electrical, mechanical, and plumbing. But we also do things like fire protection, which is sprinkler design, fire alarm, smoke detectors, that kind of thing. We'll get into more of that in a little bit. Technology design, security design, even. And then so some other things that we do, we have construction administration, we do lighting systems, lighting control. Everything now is what's called addressable. So, you can zone out however you want your lighting fixtures to look, and you can color changing, anything you want to do pretty much with lighting is is available now. Also commissioning, if we put out a design, we put out our blueprints, we put out our specifications, and once the project's built, we go back and make sure that it was built to our specifications. We also do a lot with renewable energy, solar, geothermal. We'll go over geothermal in a little while. That's under the HVAC scope. And then energy auditing, analysis, and building information modeling. A lot goes into that in a building. A lot goes into making a building sustainable. Everything from the materials that you use to the windows that you use to the type of mechanical HVAC system that you have to the panel, to the electrical system, to the lights. Everything kind of contributes to that, to making a building more sustainable or even net zero possibly, which we've done with some of our school projects. So let's keep moving on.
So the project we're going to be going over today is actually at NC State in their Partners One building. It's called the high bay space. And Gensler, the architects that are also a part of the ACE Mentor program, they actually came to us with this project and asked if we'd like to do the engineering systems on this project. So that being said, a lot of our work that we get as a engineering firm is from architects. I'd say about 90%. We get the architects come to us and say, hey, we got this renovation that we'd like to get your help on. We'll go through, we'll take their plans and we'll lay out our mechanical systems, plumbing and electrical systems on their plans and give those to the contractor for them to build. So for this project, this space, it was, as you can see here on the left, the existing conditions, it was more or less just an open warehouse storage area at NC State with some really high ceilings. That's what we call a high bay, a space with really high ceilings, like we're talking 30 feet here. So the space was actually big enough that we could make a 2-story office type space with a area with a break room, conference room, actually multiple conference rooms, and also a area with a maker space for the NC State students to come and work on their projects.
All right, so we'll jump right on into kind of the plumbing engineering side. Plumbing engineers' jobs are basically anything that has to do with piping. It could be hot water, cold water, they go to your sinks, your toilets, those kind of things, your showers. But also, say you have like a medical space, it may be compressed air, gas piping for if you have a kitchen. Like some of y'all have kitchens in your kiosks. So you got to think, do you have electric equipment? Do you have like an electric stovetop, or do you have like a gas burning stovetop in your kitchen? So you have to kind of think about things like that. What kind of do you need gas? If it's going to be portable, you probably want to go electric, because you would have to have like a gas tank like on the back of your trailer, basically. Other things that plumbing engineers handle: stormwater systems, roof drainage. Big high rises, these things have flat roofs, so they have to make sure that that the water has somewhere to go during the flood scenario. You also have sanitary waste and venting. What do you do with waste? And then utility systems, like I said, gas, main water connections, that sort of thing. So let's get into the plans here. So these are, plumbing, electrical, fire alarm, mechanical, we're all producing, the final product is we're producing a plan, or like you would think blueprints. And so this is the plumbing demolition floor plan. So basically we go into the space and they say, okay, what are the existing conditions, basically? What's available? What does the owner need? How many toilets, how many restrooms, how many break room sinks are they going to have? And then you go in, you say, okay, what's existing? What can I do with this? What can I reuse? What do I need to get rid of? And so like here in this picture here, you can see we had to cut up the slab. And in the blueprint there, it's marked to demo everything back to basically the source where the water comes into the building. And then we're going to do new construction from there. So we actually had to tear up the slab, which you try not to do, but it's always going to be necessary to do it right when you're making a new space like this. Keep going into the new construction here. So as you can see, the plumbing scope was semi small on this job. We had 2 break room sinks. So basically, we demoed back everything that was existing in there, fed the two new sinks, and that was pretty much it for this plumbing scope. Now, the plumbing engineer also does fire alarm as well, or fire protection as well, which we've got on the next slide here. As you can see these pictures, this is on the far left, that's a standpipe where a firefighter can come in, hook their hose up, and you see these in parking garages. Sometimes you'll see them in stairwells. In the middle, you have a sprinkler system, like a sprinkler riser, and a sprinkler head. You see those all over the place in your schools. Depending on where you're at right now, if you're at your house, you probably don't have any sprinklers, but if you're sitting at school and you look up, you'll probably see a few sprinkler heads. That falls under a plumbing designer's scope. And so the fire protection drawings are going to look kind of like this, like we've got here on the next slide. Basically, they come in, this is a demo, so there was already an existing fire protection system in place, water system with all the sprinkler heads. We had to come in, we were putting in new HVAC, which we'll cover here in a little bit, but there was a large duct basically that was going to have to run underneath some of the existing sprinkler heads. So those had to get demolished, and then we're going to have to add some new ones, as we'll see here on the new work construction. Yeah, so as you can see in the top picture here, that's what architects call a cloud ceiling. So the ceiling's not actually connected to the walls, and so NC State, when you're designing something, you want to think of what are the owner's requirements. What is my end goal for this design? And so you have to ask, different owners are going to have different requirements. NC State requires full fire protection coverage. So this cloud ceiling, there's actually like what's called I guess it would be a plenum space, Morgan, above the cloud ceiling. And so we had to have sprinklers basically at the ceiling for the classroom area, but there are also new sprinkler heads above that are up higher to make this full coverage, basically to cover, if you had an electrical fire above the ceiling as well. So that's pretty much the scope of the fire protection engineer. Our plumbing designers handle the fire protection. Along those lines of fire protection, we also have fire alarm engineering, which is handled by the electrical engineers. You have the fire alarm panel, the control panel over here on the left. You have notification devices like strobes and horns, or a voice evacuation system in a large building, a high rise, or a school. That basically, it has a recorded voice that tells people like where the exits are, what the scenario is, and kind of directs people to safety. On the top, you have a smoke detector, just like you would have in your house. They'll be building connected rather than the standalone battery powered ones that you might see in homes. And then you have a pull station all the way over there on the right that you see in schools and other buildings that someone could basically clear the building in a case of an emergency. So here's our fire alarm plan. Basically, we have laid out all the smoke detectors. We have the fire alarm control panel located. We have multi-criteria smoke detector that may also have like CO or gas combo, or maybe a heat and smoke detector combo. You also have duct detectors in here, which is basically a smoke detector mounted inside of a mechanical duct. So if it senses any smoke inside the mechanical system, inside the duct, possibly from an electrical fire in one of the fan boxes or somewhere or another space, it'll shut that unit down to keep smoke from being spread throughout the building and alert the fire alarm and set off the fire alarm, clear the building, keep everyone safe. As you can see here, this is a smoke detector. We got a picture of one here in a conference room. We have full smoke coverage here. And so you'll be laying this out in your kiosk, to have fire protection in your kiosk possibly. We also have mechanical engineers on staff that basically they work on HVAC design. This stands for heating, ventilation, and air conditioning. just like in your house, you have a heat pump, most likely. Probably have a heat pump outside and an indoor unit, maybe inside somewhere below your house or in the attic, possibly. These would be for smaller systems. This is probably what I would recommend for your kiosk or your mobile units to keep that heat heat and cool it. Keep it. There are other things that these systems do as well, like make sure that the air stays dry enough and it doesn't get too humid or damp to prevent mold and things like that. Down here on the bottom left, that picture there, that's what's called a geothermal system. You know, we talk about sustainability and making sustainable buildings and net zero buildings. And basically what that system does is it takes pipes and it takes them straight in the ground, 300, 400, 500 feet down, depending on the quality of the soil. And basically they run water through them and it comes back out at the temperature of basically the earth, which is around 56 degrees usually. So they use it for heating in the winter and cooling in the summer. It's kind of like a dual system that can do both. And it's really sustainable. All they have to do is use pumps. They save a ton of energy by using the thermal mass that is the ground. You see on the bottom or in the middle picture, that's basically duct layout in a high bay. In a high bay space. And then over here on the right, you have a rooftop unit that would run more conventional kind of older style mechanical system that you'll see on larger buildings out in the cities. So here for our high bay space, basically they had it was one large open area. They had basically one big duct that was linear throughout that goes from the bottom of the plan that shoots out to the left that has different diffusers or air terminals that just kind of shoved air into the space. So we had to get rid of that because we were making multiple spaces, multiple conference rooms, multiple areas, and they would all need their own zones basically. So they would have individual control. So here's the new work plan. You can see all of the air terminals and all the ducts on the plan. This allows for better control. So each room or each group of offices maybe might be controlled. So somebody wants their set at 74 and somebody else wants their temperature to be 68. So it's not just one big space anymore. They have a lot more control over it. This is the duct layout. As you can see down this corridor, we had to get everything coordinated between all the trades. You can see the lights down that corridor. You can see the exit sign. You can see the mechanical duct. You can see the plumbing pipes, the fire protection pipes, and even the electrical conduits up high that run down through there. And all that has to be coordinated within our office and with the architect. In the top photo here, this is some vents. Those are some 3D printers. Basically, they put off some fumes that people don't need to be inhaling. And so anytime you're working with a 3D printer, they'll pull these vents down, turn them on, these exhaust fans, and will exhaust those fumes away from people and basically keep people safe and keep the fumes from harming the operator.
So we'll go into electrical engineering. So to start off, one of the electrical engineering design types we do is power distribution. Power distribution is the design of all the panel boards and all the breaker boxes inside of a building. Like in your house, of course, you got or an apartment, you got a breaker inside your house that has all your breakers. And if you overload a circuit, like if you plug in too many lights or hair dryers or something that pulls a lot of power into an outlet, a lot of times, sometimes it'll trip that breaker and you got to go and flip it. Well, those type of panels, we have to size all of those and determine how many number of panels we need for commercial buildings. And once we determine the size, we'll go in and size those panels as far as like the ampacity, and we'll determine what size conductors we need going to those panels or wire, and how big those rooms need to be for the architect, and how all that's getting routed. Another part of our job is the lighting design, which is a great area if you're if you got a more artistic side and you also like math, because you can do all sorts of creative, cool stuff with lights. Like Spencer was mentioning earlier, you can do color changing. You can do dimming. Part of our job is figuring out what kind of controls you need for that lighting, whether it be automatic shut off or sometimes we'll do dimming that throughout the entire building that's programmed through a computer system. One of my favorite parts of electrical engineering is power generation. Renewable energy, we're talking PV, solar systems, sizing generators and UPSs, uninterruptible power supplies. For example, the picture on the top here, that's a data center, and on the left in that picture, you see they've got all these different UPSs. What those do is provide uninterruptible power to all those servers in that building. And those, what a data center is a lot of times we'll get hires from Facebook or Google or big software companies like even Amazon. Like they've got these data centers where they store all this information because you gotta have all these large servers for that to keep that information stored. And you don't ever want to lose power to those types of buildings because once they lose power, that information is gone. Access controls and security, that's like camera systems, uh, access control to your building, like card readers. We design all that stuff. Power monitoring would be more on the side of phase loss. A lot of these commercial buildings, we got three-phase power coming to them, and if you lose one of those phases, like it can be harmful to your HVAC systems, mechanical systems, and power monitoring, we can monitor that and shut off breakers if one of those phases fails. So getting into our high bay project, as part of for demolition, we pretty much gutted and removed all the lights, all the receptacles, all the panel boards inside of that space. And the only thing we tried to reuse on this project was they had a big main switchboard, which is probably about a $60,000 piece of equipment. And we didn't want to remove that and have to replace it because one thing we got to keep in mind when we're doing design is how much our scope of work is going to cost, and we want to try to keep that to a minimal for the client. Like if they've got a panel, or in this case this large switchboard that we know it would be good for them to reuse, there's no reason they can't reuse it. We want to keep that and save them some money. So that's what we ended up doing on this project. And as far as lighting goes, we ended up putting all new LED lights in that are highly efficient. We designed a control system for each individual space. For example, you can see here in the large conference room, you can see the final product here on the right. We've got these what's called linear recess lights that are LED. We got all of those lights on dimmers and zone, so which it works great for the presenters. They can dim the front row and have the lights for the students on a brighter level. Each of the offices, we have to put in automatic shut off or occupancy sensors. Typically, you'll see every new building we have some type of occupancy sensor in almost every room. And that's because these the new energy codes, as they get updated, they require more efficient equipment. Like for example, the 2018 energy code just got released, and we pretty much have to put LED lighting in all buildings to meet the max power output of that lighting for a certain area. And it's great because it keeps these new buildings really efficient, and we're required to have automatic shut off for all the lights so they don't remain on all night and just burn energy for no reason. Part of the power plan. So for our maker space, we have a large amount of different types of outlets, power for all these different types of machines, like the 3D printers, and we have power for welders, drills, different types of saws. So these students can come in and create whatever they needed for their school projects. One thing we do is on our plans we use these different types of symbols, as we'll get into with your student activity. We take these different symbols and lay them out on the architect's plans to show an electrician or a different contractor, other types of contractors, how to where to locate equipment. As you can see here, we have a symbol for a cord reel, and we located on the architect's plans here on the left and showed that they need to be mounted on the on that steel structure on the bottom. You can see that the electrician was able to understand by the plans how to mount that how to mount that cord reel, and on the right you can see the finished product, the installed product out in the field. So construction administration, this is one of my favorite parts of our job is actually going out in the field and during construction and reviewing the progress on the project and making sure that everything's getting built like we had showed on the plan. So some of the different steps to that is shop drawing review. That's when we get the actual material data from the contractors, and we have to sit down and go through it and make sure and compare that to what we show on the plans and make sure that it meets our design requirements. And if not, we tell them, okay, well, you need to revise this, and then we send it back to them and they fix that. Request for information, that or RFIs, we get those from the contractor. That's when the contractor, he looks at our plans and said, oh, well, this engineer, they show that this can't actually be built like they show it on the plans. So they send us a RFI and tell us, hey, you can't, for example, you can't install this receptacle in this wall. Here's what we suggest. We suggest moving it to a different wall. And we review that, and if it looks good, we'll tell them, yeah, that's fine, move that receptacle. Or well, if it doesn't work the way they suggest, we'll give them a different solution. Construction field review visits. We actually go out in the field on projects. It might be once a week, it might be once a month, and determine are the materials actually getting installed like we show them on the plans. And a part of that's inspections. We'll do what's called an in-wall rough end inspection. As you can see on the picture on the bottom left here, they've got all the wall studs up, and they've got the wire and the junction boxes for the electrical devices routed in that wall. So we'll go out and take a look at that and make sure there's nothing's been broken during construction, and we'll verify that it's installed as we show on the plans. They show receptacles where we show them, and everything's all the wires run as we tell them to on our plans. So here's just a couple pictures of the final product of the high bay space. Ended up looking awesome. As you can see here on the top left, we got a student. He's created a octopus on one of the 3D printers, and we got all sorts of different open ceiling spaces where you can actually see their mechanical systems. They got a break room on the right where they can make coffee and eat together. We got a couple new conference rooms, and there's a final picture of the maker space here on the bottom right. So for your student activity, I would like for you guys to take your building and lay out our electrical devices on your plans. Or also too, we got mechanical devices. You can see our symbol legend here on the top left. We got symbols for TVs, receptacles, different light fixtures, smoke detectors. Here's an example of my project that I put together. As you can see, I got a new breaker box in the in my space. I got receptacles all throughout. So the idea of my project, I wanted to create a like a tiny home that you can live in. It's also mobile. I've got created a ladder to access the second floor. The second floor is going to be the bedroom area. Um, got a TV wall box that'll be behind the TV. That way you can't see the cords. We got a under counter lights. That way you can see for food prep. Got the lights all switched right there at the door. Got an exhaust fan in my restroom. So yeah, take your plans and lay out lay out our electrical symbols and get creative about it.
They're also doing a pedestrian bridge basically, and we want to think about lighting this pedestrian bridge, right? You know, the electrical design or the MEP design for this. And so basically what I'm going to have y'all do is I've given you a list of basically websites that are lighting websites. They make a bunch of architectural lights, color changing, different colors, different shapes, all sorts of things that you could go on and find, or you could find, you know, you could just use Google and see what else is out there that you can find. But basically select, you know, 2, 3, 4, however many fixtures that you want to do. You can do pole mounted, you could do linears, you could do tape lighting, you could do color changing, you can do dome lights, and lay those out on your bridge, basically. Select them, take a screenshot, paste it to the, put it on your plan so you can kind of visualize what it's going to look like and lay out where you want each fixture to be. Here's basically the project that I did. I've got, as you can see, I've got waterproof receptacles on either side of my bridge. That way when maintenance person comes out, they have somewhere to power their tools. You also have like a small breaker panel with a photocell on it that basically when it gets dark outside, the lights are going to come on. Basically what I chose for my bridge here is a lighted handrail system. So I've got, you know, handrails for the pedestrians, and the inside the handrails, there's basically strip lights built in as part of the handrails on the bottom side that lights the path, but doesn't light pollute straight up into the sky and basically cause light pollution, bothers animals and other sorts of problems that light pollution can cause. On the bottom, you can see that I've got these programmable color changing LED lumen domes by Lumen Pulse. That website's on the plan activity if you want to go check those out. And you can see some other bridges where this has been used. They're blue there, but they can be any color. You can make them programmable, where you can change each dot. So you could go like green, red for Christmas. You could do anything that you wanted to do. You can make them move, you can make them blink, you can bring attention, like if there's, I believe, is there a train coming under their pedestrian bridge that they're designing? So, you know, you might want to have lights on there to, you know, alert the train that they're about to come under a bridge at night so that they can see it. But get creative with it. Just kind of browse around and see what you can find. But either way, have fun with it. And that is the end of our presentation.